At the hour of its send-off, NASA didn't realize that the Voyager mission would become one of the greatest space endeavors in history. The Voyager probes, launched during the 1970s, have not only persistently observed Earth but also everything within our solar system and beyond. Despite having a memory capacity 3 million times less than our cell phones and being over 10,000 times slower than the fastest 5G internet connection, these remarkable spacecraft have consistently provided humankind with new and astonishing data about space. Now, Voyager 1 has made a terrifying discovery deep within interstellar space, prompting the government to take decisive action by shutting down this incredible mission. What exactly did Voyager 1 encounter, and could we be on the brink of an extraterrestrial invasion? Let's find out. When it comes to U.S. space missions, the Apollo mission often takes the spotlight for successfully landing the first humans on the moon. However, there is undoubtedly another extraordinary mission that stands tall alongside Apollo, the Voyager mission. This unique endeavor not only holds the record for the longest-lasting space mission but also has the distinction of being the first to explore the outer planets of our solar system, from Jupiter to Saturn, Uranus, and Neptune. The Voyager probes, in particular, are considered the most suited for possible encounters with extraterrestrial life due to their comprehensive design. Each Voyager spacecraft carries a special golden record containing a collection of sounds, images, and greetings from Earth, serving as a snapshot of humanity and showcasing Earth's rich diversity, a gift that any potential alien civilization could appreciate. However, what if these wonderful probes were to encounter a hostile extraterrestrial race? Based on the signals we are currently receiving, this is possibly what Voyager 1 is dealing with right now. This possibility has left scientists pondering the outcomes, as such an encounter could prove more devastating than initially imagined. Keep reading as we dive into the events that led to the government's decision to shut down Voyager 1 and discuss the potential implications. Before we dive into those details, let's provide some important context. On September 5, 1977, Voyager 1 embarked on its space odyssey from Cape Canaveral in Florida. It was launched into space by the Titan IIIe Centaur rocket just 15 days after its twin, Voyager 2, began its own stellar journey on August 20, 1977. Their primary mission was to explore the massive gas giants of our solar system, specifically Jupiter and Saturn and their orbiting moons. However, these bold explorers exceeded all expectations by venturing deep into our infinite neighborhood, breaking numerous records along the way. They have surpassed all other spacecraft in longevity and have traveled farther from Earth than any human-made object, even penetrating the boundary of interstellar space and wandering into strange realms of our galaxy. Remarkably, Voyager 1 and Voyager 2 now live over 12 billion miles away from our planet, continually baffling scientists with their astonishing discoveries. Recently, they made an unexpected discovery that left the entire scientific community in awe. The Voyager twin probes have accomplished extraordinary feats. More than 40 years ago, they revealed the mysterious moons of Jupiter and Saturn, leaving scientists astounded. These celestial bodies, once thought to be dark and crater-ridden like our own moon, were uncovered to have vibrant and dynamic natures. In 1986, Voyager 2 became the first and only spacecraft to venture into the realm of Uranus, followed by an exhilarating encounter with Neptune just 3 years later. As these incredible spacecraft press ahead with their inspiring odyssey, NASA has implemented clever measures to ensure their operational longevity. By deactivating unnecessary components and heaters, power is conserved, allowing the spacecraft to remain functional until at least 2030. The dedicated scientists and engineers behind the Voyager missions were taken aback when an astonishing discovery came to light, so profound that it prompted government intervention in one of NASA's most prestigious projects. But before we explore that, let's discuss the Voyager mission's reputation. Why is Voyager 1 such a big deal, and how has it transformed our understanding of space? Among the ranks of iconic missions like Apollo 11, the Hubble Space Telescope, Mars rovers, and the James Webb Space Telescope, the legendary Voyager program stands as a beacon of inspiration for future generations of scientists and astronauts. The data sent by the Voyagers has yielded invaluable insights, ignited countless scientific discoveries, and captured the imaginations of scientists and space enthusiasts across generations. It is worth emphasizing that Voyager 1 and Voyager 2 were no ordinary spacecraft. They were meticulously crafted to operate as stable platforms with a rotation rate more than 10,000 times slower than the hour hand of a clock. This deliberate design ensured minimal blurring of images and data as the spacecraft zoomed through the vast expanse of space. Their impressive imaging capabilities continued to amaze scientists and the general public alike, even before their encounters with the outer planets. As the spacecraft traveled toward Jupiter, they began transmitting images months before reaching the gas giant. These initial images, displaying the swirling clouds and the iconic Great Red Spot, filled NASA's Jet Propulsion Laboratory with pure wonder. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly stole the spotlight. Io, slightly larger than Earth's moon, emerged as the most volcanically active body within our entire solar system. The spacecraft's instruments detected unusual signals emanating from Io, and stunning images they captured confirmed these remarkable findings. These pictures unveiled towering volcanic plumes and a surface marked by the eruption of volcanic material. Notably, one of Io's prominent volcanoes, Pele, erupted to heights exceeding Mount Everest by a staggering 10 times, covering an area nearly comparable to the size of France. Altogether, the Voyager spacecraft snapped over 33,000 images of Jupiter and its moons, revealing the planet's breathtaking beauty and the astonishing diversity of the Jovian moonscapes. Before diving into the recent mind-blowing discovery, it is important to remember that the twin Voyagers have been uncovering a wealth of astounding findings since their groundbreaking launch. One of the most surprising discoveries was the presence of Jupiter's rings, which, although faint, added an extra layer of intrigue to the epic gas giant. Furthermore, Voyager 2 uncovered the icy shell encasing Europa, one of Jupiter's 53 named moons, estimated to have a thickness exceeding 60 miles. Imagine these momentous discoveries tested recently held suppositions about distant heavenly bodies, sparking a renewed enthusiasm in examining the potential habitability of cold moons. As the explorers bid farewell to Jupiter, they received a crucial gravity assist that boosted them towards Saturn's captivating realm. Without this ingenious move, their escape from the Sun's gravitational pull and subsequent journey into the depths of space would never have been possible. Thus, Explorer 1 and Explorer 2 embarked on separate trajectories, each venturing toward uncharted frontiers, eager to unravel new wonders. Explorer 1 took a course close to Saturn's moon Titan, shrouded in a mysterious orange atmosphere. Scientists became intrigued by the enigma of this moon, prompting further studies on its complex chemistry. Then, Explorer 1 veered north, away from the plane of the planets, embarking on a unique voyage beyond the boundaries of our solar system. Meanwhile, Explorer 2 set out on a fascinating series of encounters that carried it to the outer planets. In 1986, it achieved a historic milestone by flying by Uranus, unexpectedly discovering 10 previously unknown moons, expanding Uranus's moon count. 3 years later, Explorer 2 reached Neptune, revealing the extraordinary characteristics of this distant ice giant. During its encounter with Neptune, the spacecraft recorded wind speeds of up to 1,000 miles per hour, the fastest winds ever observed on a planet within our solar system. By zooming within 2,980 miles of Neptune's methane-rich atmosphere, Explorer 2 provided unmatched insights into this faraway world. One of Neptune's moons, Triton, emerged as one of the coldest places in the solar system, with surface temperatures plummeting to a frigid -391 degrees Fahrenheit. Triton also exhibited unique features like ice volcanoes spewing nitrogen gas and icy particles up to 5 miles high into its thin atmosphere. These discoveries deepened our understanding of the diversity and complexity of celestial bodies, even those at the farthest reaches of our cosmic neighborhood. A key figure in extending these missions beyond their initial goals was the esteemed astronomer Carl Sagan. As a member of the Explorer mission's imaging team, he passionately advocated for capturing one final set of images before deactivating the cameras. These images would serve as a memento to humanity, offering a last glimpse of our home planet from the distant depths of space. Sagan's persistence paid off on Valentine's Day in 1990 when Explorer 1 turned its camera back toward the inner solar system and took a series of 60 photos. The most iconic of these, known as the pale blue dot, remains a profound symbol of our place in the universe. Captured from an astounding distance of 3.8 billion miles, it stands as the farthest image of Earth ever taken, showing our planet as a tiny speck, barely visible in the vastness of space. This mission has continued for nearly 50 years, often compared to later space missions. One such mission, which has made remarkable scientific contributions, is the James Webb Space Telescope, JWST. Although their objectives and scopes differ, both projects have pushed the boundaries of human knowledge and expanded our understanding of the universe. The Explorer spacecraft were marvels of their time, equipped with state-of-the-art instruments and systems that allowed them to endure harsh conditions and maintain communication with Earth over immense distances. Similarly, the JWST incorporates cutting-edge technologies like a deployable sun shield to protect its delicate instruments from the sun's heat and a large segmented mirror to capture faint infrared signals. While the Explorer program focused on our local cosmic neighborhood, the JWST aims to unravel the mysteries of the universe on a grander scale. Its advanced capabilities enable scientists to peer back in time, observing the earliest galaxies and shedding light on the formation and evolution of our cosmic environment. The success of the Explorer missions can be attributed to innovative techniques like gravity assist maneuvers, which proved to be the key to unlocking the secrets of the solar system and propelling these spacecraft to the farthest reaches of space. Humankind ventured into the domain of the unexplored world. Picture this, a grandiose, expressive dance where the rocket nimbly embraced the gravitational powers of the strong planets, harnessing their capacity to steer towards their intended destinations. Rather than relying solely on their own engines, the explorers carefully used the enormous pull of the celestial giants to slingshot themselves across the vast cosmic stage. It was a brilliant idea and a shrewd move that conserved precious fuel and propelled the spacecraft with phenomenal speed, enabling them to embark on a remarkable grand tour of the solar system. At the core of this strategy lies the concept of gravity assist, otherwise known as the gravitational slingshot. As Voyager 1 approached Jupiter, a magnificent gas giant with a gravitational force that defies comprehension, it required careful precision to navigate the perfect encounter. Guided with meticulous attention to detail, Voyager 1 gracefully swung around Jupiter, harnessing its gravitational pull to accelerate the spacecraft with an awe-inspiring burst of speed, an immense cosmic push that propelled it further into the depths of space. Yet, executing such a maneuver demanded an exceptional level of skill. These gravity assists became the driving force behind the incredible odyssey of Voyager 1 and Voyager 2 through our planetary system. Think about the monumental achievements made possible by these slingshot maneuvers. Voyager 2, propelled by gravity assists from Jupiter and Saturn, embarked on a daring journey to Uranus and Neptune, completing the sweeping grand tour. It was a triumph of human ingenuity and exploration, owing a boundless debt to the precision and finesse of these gravity assists. Voyager 1, venturing boldly into interstellar space, was followed closely by Voyager 2. Both were propelled by the cosmic pushes provided by these maneuvers. The concept of gravity assists may seem deceptively simple, but its execution is a testament to the brilliance and dedication of the people behind these missions. The grand tour undertaken by Voyager 2 demanded meticulous accuracy, where missing even a single slingshot could have spelled catastrophe for the mission. Yet, with unwavering determination, these pioneers of exploration pushed the boundaries of what humankind could achieve, driven by an insatiable thirst for knowledge and a deep longing to unravel the mysteries of the universe. While the gravity assist maneuvers played a vital role in navigating the cosmos during the Voyager missions, they were not alone in ensuring the success of these daring undertakings. Enter the Deep Space Network, DSN, a lifeline connecting us to our intrepid Voyager probes as they ventured into uncharted realms. Think of it as the Interstellar Communication Network, a tapestry of immense radio antennas strategically placed across the globe. These colossal dishes, ranging from 26 to a staggering 70 meters in diameter, acted as cosmic beacons, enabling essential communication with the spacecraft beyond our planet. Imagine the Voyager mission as a grand odyssey, propelled by a remarkable artifact that transcends time and space, the 8-track tape. This striking relic serves as a cosmic time capsule, housing invaluable scientific data as it plunges through the vastness of the universe. Unlike standard consumer cartridges, the 8-track tape recorders used on the Voyager probes were a marvel of engineering. Featuring a reel-to-reel capability system designed by Lockheed and manufactured by ODC Company, these impressive machines boasted specific specifications offering flexibility and precision. Recording speeds included options of 115.2 kilobits per second, kbps, and 7.2 kbps, while playback speeds ranged from a maximum of 57.6 kbps to slower options of 33.6, 21.6, and 7.2 kbps. The reliance on these exceptional 8-track recorders within the Voyager mission epitomizes humanity's enduring commitment to scientific exploration. As these probes venture deeper into the universe, the enduring legacy of this timeless artifact continues to preserve and disseminate our unquenchable hunger for knowledge. The Voyager missions have sparked awe and wonder in all of us, preparing us to journey into the vastness of interstellar space. Before we delve into the discovery that led to the conclusion of Voyager 1, let's take a look at other intriguing interstellar missions, Pioneer 10, Pioneer 11, and New Horizons. These missions have played a crucial role in expanding our knowledge of the solar system and beyond. Picture this: it's March 2, 1972, and Pioneer 10 sets off on its groundbreaking mission. It becomes the first spacecraft to venture beyond the asteroid belt, traveling into the uncharted territories of the outer solar system. Its mission? To conduct flybys of Jupiter and its mysterious moons. On December 3, 1973, Pioneer 10 achieved a remarkable feat. It became the first human-made object to travel through the asteroid belt, offering us invaluable insights into this mysterious region of space. But the excitement doesn't stop there. Pioneer 10 wowed us with breathtaking images and groundbreaking scientific data as it performed a close flyby of Jupiter, capturing the essence of the gas giant and its mesmerizing moons. Pushing further into the unknown, Pioneer 10 became the first spacecraft to cross Neptune's orbit in June 1983, etching its name in history. Although we lost contact with Pioneer 10 in 2003, it remains forever the Pioneer, the first man-made object to venture into interstellar space. Following in Pioneer 10's footsteps, Pioneer 11 took the stage on April 5, 1973, with similar goals. It embarked on a daring adventure, and December 2, 1974, marks a significant milestone as Pioneer 11 successfully conducted a flyby of Jupiter, bringing us awe-inspiring images of the gas giant and its iconic Great Red Spot. But Pioneer 11 didn't stop there. It embarked on a grand mission to unravel the mysteries of Saturn and its enchanting moons.